Hi everyone. We are going to talk about gRPC and Python. I got the name when gRPC met Python from one of the references. So if you're not able to get exactly, so we are going to talk a bit about gRPC. And if you have never interacted with gRPC before, then we are going to see how easily we can directly interact with gRPC in Python, right? A little bit about me. I'm Sanket Singh. I work as a software engineer at Google. Prior to Google, I worked with LinkedIn as a software engineer. I spent some of my time in also training students in India around foundations of computer science, DBMS, data structures, algorithms, along with a bit of JavaScript, Python, etc. Right. I'm kind of like superhero fan, so a bit of Marvel and DC references, so no differentiation whatsoever. I love both. Okay, so without further ado, let's get started. So what to expect from this session? We are going to discuss about why and what around gRPC, because from past quite a lot of years, REST as a convention, JSON APIs is something that we are quite familiar with, right? So why this as a new convention and a new technology? So we're going to talk about that. We'll see a bit of comparison between gRPC and our favorite REST, and we'll try to kickstart a basic server and client thing in gRPC, obviously with Python. We're at PyCon, right? So we'll do that. So let's have a quite brief around our favorite REST, right? So REST has been with us for quite few time. It's like widely accepted and used. I'm not sure, I'm not exactly correct with the statistics, but I believe everybody sitting in the room, if they have interacted with some kind of server, I would say code, then they must have interacted with some JSON APIs, REST APIs, RESTful APIs, right? So it's part of our, as a developer, it's part of our life. It's kind of flexible, easy to use. A lot of libraries are there which supports REST. You are able to easily consume REST and a lot of things, right? Apart from that, compatible with browsers. So REST, because of the time REST has spent with us, we have been able to interact with REST using directly with browsers. Not only through client libraries, we are able to connect with the REST APIs, but directly through browsers, right? We can directly make an XML HTTP request using the browser and using the JavaScript, and we are able to connect with REST. It has got a predefined set of conventions, how to design the URLs. It should be resource oriented, right? I believe everybody must have heard about resources. So we try to make our REST APIs resource oriented. The CRUD conventions are obviously there. There are a lot set of status codes, right? So you can check out MDN to learn about all the status codes that we already have. So kind of like it's there, the set of conventions are there, we are kind of like familiar with it. And obviously frameworks like Django and Rails, they by default come with a lot of RESTful, I would say, generators and everything, so that whenever you're creating your MVC architecture with controllers, models, routes and everything, the REST API comes by default out of it. I believe or a lot of you must have used Django or Ruby on Rails. So you might be familiar with the out-of-the-box REST capabilities that they came up with, right? So today we'll be talking about gRPC. It was REST, but now we have something called as gRPC, right? I believe everybody must have heard about RPC, remote procedure calls. So it's gRPC. What G stands for, nobody knows. It's a speculation that G stands for Google, because gRPC was developed by Google in 2015, but they don't mention it anywhere. So just a speculation. I'm not saying it's Google RPC, but you'll find articles there. There are a lot of things that they updated here. They are now by default out of the box using HTTP 2.0, right? It's a language neutral protocol. It uses language neutral protocol buffers. We're going to talk about protocol buffers. It's one of the main key highlights that gRPC provides, right? And it's fast, secure. It has capabilities like auto load balancing and a lot of things, right? So this technology that was released by Google is one of the main things that, like, as in Google also we use, At Google, we write a lot of gRPC, right? I've been working with some of the Google Cloud-based products. I now work with Google Pay. A lot of server-side interaction that we do, and in inter-service communications also that we do. Most of the things are done by gRPC. So we are like heavily loaded with gRPC at Google, and let's see what gRPC has to offer us. But the thing is, why now? We were having REST, right? Why are we not too much comfortable with REST, and why do we need something else? Like, we already had a lot of convention. We had SOAP, I believe, Simple Object Access Protocol. I believe everybody must have heard about it. The XML things, right? The big XML that we used to send. Then, obviously, REST came into the picture. JSON API is cool, simple, right? And then a few other conventions came, and now we have gRPC. So why now? So we are going to talk a bit about problems that comes with REST. Just a disclaimer, these problems can be opinionated, right? You might not see this as problems, but yes, these come as some of the things that the REST conventions doesn't directly provide. So they can be a bit problematic at some times. For example, JSON has got some issues like type checking, right? When you're sending data with JSON, JSON is the main message format in REST. So there might be some issues with type checking that you can have. Apart from that, you can have some semantic versioning, right? This semantic versioning is like according to at least the convention. If you don't want to follow the convention, I don't think anybody is going to scold you for REST, but you have to do the semantic versioning. It's expected, right? Even the automatic generators from Rails and Django, whenever you use those generators to generate the code, they kind of like use that all versioning and semantic of the resources and everything and give you the APIs, right? REST doesn't support very well things around streaming that obviously gRPC is going to do. It by default supports HTTP 1.1. You can migrate to HTTP 2 also, but the default support is there for HTTP 1.1. It's a bit slower than HTTP 2.0. I'm not sure how many of you guys have heard about HTTP 2.0, but yes, it's a bit slower. You need to do a bit of manual validations at a lot of places for the APIs. And one of the, I would say, main key highlighting points are the maintenance of the client-side libraries, right? You use JavaScript, Python, Ruby, C#. Everybody has their own client-side libraries, right? Different frameworks, different languages, different environment, different libraries. And if there are different libraries, maintenance of different libraries is going to be an issue, right? Maybe some libraries are going to be migrated to new standards, some might not, right? So the issue with these separate set of client-side libraries and their implementations is definitely going to be there. So gRPC to the rescue. gRPC is going to provide a bit of help around some of the issues that come with REST, right? By default, HTTP 2.0 support, so multiplexing and all, you can directly do, right? So it comes out of the box, HTTP 2.0 support. I'm not saying you can't do HTTP 2.0 in REST, but if something is coming by default, it's good, right? Instead of JSON, the main key highlighting point is it uses protocol buffers, proto buffers, proto buff, proto, whatever you want to say, right? This is one of the main messaging, I would say, format that gRPC uses. It's strict. First of all, it's strict. And it's kind of like optimized. The serialization and I'll be showing some examples about the serializations of protocol buffer that it is going to serialize your data in binary format. So it's going to be small. And obviously, if the message that is going to be transferred is going to be small, it's going to be fast, right? As I said, strict API contract, this capability is coming out of protocol buffers. So because of the strict API format that protocol buffers brings to the plate, that's why gRPC also is having it. And Google has done some good amount of work there. And they have given us the code generating capabilities. So whatever is your environment, whatever is your client-side technology, Google has given us the compilers that is going to compile the proto, and it is going to generate a lot of code for us. I'll be showing you what kind of code gets generated, at least with Python, we are going to see. It has capability of inbuilt load balancing, right? Like the client side can automatically choose which server to hit based on the current load on the servers. It gives us not only the capabilities of unary, I would say, interaction, but also server-side streaming, client-side streaming, and bidirectional also, right? So these capabilities come out of the box for gRPC. It's secure, right? One of the main reasons for it is the serialization that is being done by the proto buffers for your data. And of course, it's faster, right? That's the main selling point, that it's faster. It's faster than REST. If you'll go by the statistics that you're going to find with a lot of GitHub implementations that you're going to find, it's approximately 7 to 10 times faster. But again, that can depend on use case to use case, right? So it's a bit faster than REST. But how is it faster? How exactly is it faster, right? That is something that is, again, as I said, protobuf is going to do. It serializes and deserializes data into binary. So the overall message size gets reduced, right? In SOAP, we used to send directly the XML, right? That was the serialized format. In REST, we have JSON. Here we'll be sending binary. So obviously, the messages become light, small, easy to transfer. Uses HTTP 2.0, that automatically enhances the capability because multiplexing and all is directly available. It supports streaming. It has inbuilt capability of load balancing. We have already talked about this. So these are some of the main key highlighting features that gRPC has got that helps us to actually increase the speed increase the performance of the overall application. So here you can see, I got this from one of the very interesting Medium articles. Just to mention everything that I'm going to talk about and a lot of references about the articles, official documentation, I've already attached in the presentation. So in the speaker notes, I don't have any notes for me, but instead some good links that you can also refer. So this was taken by one of my favorite Medium articles and one of those articles that I read, and I enjoyed reading them a lot. So it shows that the string medium gets serialized by the protocol buffer, and you can see this format, right? This is what gRPC is going to do. This is our favorite XML and our lovely JSON, right? So you can see the overall message size is quite small. And just for a very small string medium, just a second. If you're going to send something like this big, it doesn't make a lot of sense, right? But this is quite small, right? This is quite small, and the overall binary format helps us a lot. So according to the official documentation of Google, if you read about what are protocol buffers, because if you're still not able to understand what's protocol buffer, it's a language neutral, platform neutral, extensible mechanism for serializing structured data. Think about XML, but smaller, faster, and simpler, right? So the same thing, but that comes with a package that is going to be a bit faster, a bit smaller, and obviously better. Apart from this, Google took it on themselves. So for whatever environment or whatever language you are going to use in order to do the interaction between the services, Google is going to provide generators that is going to help you to automatically generate the code, automatically generate the client-side code for whatever language you are having. Python, be it Ruby, be it C#, anything. Like you can go to the official documentation. After the latest release of Proto version 3, they have even extended the capabilities to languages like Kotlin and everything. Right, so Google took it on themselves, and everything is going to be developed by Google. So obviously, if anything comes new, right? If any new, I would say, implementations are done, Google is going to handle that. You don't have to care about it, that okay, whether the client-side library is handling that or not. And the best part is Google also abstracts a lot of implementations around HTTP 2.0 so that the end user doesn't have to care about how exactly they are going to make the changes. So that's one of the best parts, right? And we love Iron Man. So let's see that how can we implement a basic, simple server and a client in gRPC. We are like a lot of good advantages of gRPC I have talked about. I'll be also talking about some of the disadvantages of gRPC, right? So I came prepared that if we will be having a lot of time, we can do hands-on coding also. But I have the code snippets also, and I can just run them in front of you. So let's see what's there with us. So whenever we have to define a proto, so I'm going to show you how you can build a basic to-do. Everybody must have built a to-do, right? At least I built it at least 10, 20 times when I started learning everything. So if we want to build a basic to-do service where we can create a to-do and let's say read a to-do, that's it. So this is how you write protocol buffers. You just mention what version of protocol buffer you are going to use, proto 1, 2, or 3. Obviously, we are going to use 3 because that gives us extended capabilities. We are going to mention it as a package. And this section, the service to do, this is going to mention our main RPC, right? With what RPC we are going to communicate, this is going to mention it there. So when you mention RPC create to do, what's the expected input to your RPC, to your procedure call, and what's the expected return format? Same here. And the input and the return format, you maintain it as a message. So you can see message to do item, message to do items, right? And message to do request. In these messages, the best part is you can have strict data types, right? So for example, I want my text always to be a string and ID always to be an integer. What are the data types supported by the protocol buffers? Of course, you can go to the official documentation and there you can read about it. But if let's say we just want our ID to be always and always integer and a text should be there. So we are going to define our message like this. And whenever we want to send a to-do item, it will become strict. It will become mandatory for us to send an ID and a text. It's not like if you're not sending, it is going to accept it. Or if you're sending it in a different format, it's going to accept it. No, it's going to be strict. Right, so this is going to help us, right? This is going to help us with this is going to help us to write our services in a better format. If let's say there is something that you want it to be optional, right? For example, in REST, if I go by the CRUD conventions for REST, let's say if I want to get all the resources, then you don't pass the ID, right? Let's say if I want to get all the to-dos, so I give a get request with /to-dos. It will give me all the to-dos. But if I want to get a specific to-do, I'll just say /to-do/:ID. We mentioned the ID, right? That's how we give it in CRUD. So here also we have those kind of capabilities. You can mention a field optional. The moment you mention a field optional, it is not going to ask you to specifically pass it, because in some requests if you want, you can pass it. Otherwise, you can. If you don't want it, you should avoid it. If you want to have something like an array, there is something called as repeated field. You can mention to-do items to get repeated. So it is going to return you an array of to-do items. So this is how you are going to define your protocol buffer. You just need to mention this file, and you need to install something called as gRPC_tools. So this is a library developed that is going to help us to get some boilerplate code out of the box, right? Just mention gRPC tools.protoc. This is the compiler. This is going to help us to give directly the current protocol buffers are in. This is going to mention the output directory, right? And here we have mentioned the proto. If I show you what it actually generates, let me show you what kind of code this command is going to generate. Just a second. Okay, so here you see to-do pb2.py and to-do pb2 grpc.py. So it's going to create this whole class for us where a lot of things are already available for us. For example, this to-do service, right? Our create to-dos and read to-dos. These methods are available. A method to add your service to your server is already available. So all of this generic code is going to be created in Python. And whatever language you are using, if let's say you are using something like Ruby, you have to use the corresponding tools of Ruby to generate this code. Here we are using gRPC tools, which is specifically for Python, right? The moment you do it, you get all the piece of code available with you. You have to just include, you have to just import the generated files, that is to-do pb2, I guess this is protocol buffer, to-do pb2 gRPC, and you are going to obviously import gRPC with you. then you can start writing your service. You can start writing a service, right? It's going to have your create to do and read to do's, right? It is going to take the argument of the request and the context. Currently, I have written it as not implemented exception you can write. And here I have an array of to do's, right? After that, you can just write your basic server. In your basic server, you have to just call your grpc.server method. You already saw this function just now, add to do to server. You just call this function and add your to do service to the server, right? You mention your ports here and you say the start, you call the dot start function, and you're going to also add a function wait for termination so that it always manually wait for it, right? And then you can add your implementation. We just wrote that raise exception. Instead of that, we can write our implementation. So here you can see, if you will access the request object, you are going to get the whole to-do item as the request. Then you can start preparing your reply. You have to, let's say, send the same ID as it is, and in the text I have done some update. You can do self.todos append so that you are able to access it here, and you just do a reply. Similar thing for read to do. Like you write your implementation, simple Python that you have to write, nothing else. On the client side, if you want to prepare a client side as well, it's very easy. gRPC is going to help us with a function, insecure channel. So this channel function actually helps us to communicate the client to the server. You can read about the documentation of channel. I have added that in the speaker notes for that. Just mention the address where you want to communicate with your RPC, right? And then I believe this is going to be super easy. You have to just call your RPC here, call create to-dos. You have to just pass the to-do request. You have to prepare the to-do request here, and things are going to be done. If you want to call the other RPC read to-dos with to-do request, and here you can see, because the ID parameter was optional, I have not passed anything in the to-do request. I'm just passing it plain simple object, and we are just going to receive the response. So it's going to be like just making few function calls. That's the benefit of RPC, right? You make these calls just like you were having an object in your system only. So if you will try to run the code of the server and the client, from the client if you try to interact, then this is what you will get on the server. Server will send the response, and you are going to get a response like this, right? So very simple to get started with a gRPC server and client in Python, because everything is out of the box being done, right? So, and if you will see here, the same implementation I've done as well, right? So you'll find some really good documentation that has been provided. Time for pros and cons. We talked about a lot of pros for gRPC. What are the cons? The main con that I feel is, what if we have to just build a very small application, right? What if I'm in a hackathon? I'm not going to boot up a gRPC server, right? So if you have to build something very small, right, then gRPC is not going to make sense always. And maybe the initial starting, like to get kick-started with gRPC, how exactly all of this efficiency magic is being done, maybe that can be a bit overwhelming. So I feel that is something that is definitely a con. Apart from that, already a lot of services that we have written, a lot of code that we have written is already supporting REST. Migrating a lot of them may be an issue. But the main pros that I directly find, and we have been using this at Google also, is the performance, right? When you have a very large application coming around, then it makes sense to have those strict capabilities around the messages that you are sending in between server, like two services, right? So those are the capabilities definitely that gRPC provides. But REST is never, I believe REST is not going to go anywhere else, right? It's going to be there. Maybe we are going to balance it with gRPC. But yes, I believe gRPC is a good attempt by Google to integrate the RPC environment, to integrate this performance in our services, right? So, and again, with Python with us, already the code is super verbose, and having something like gRPC, your code is going to be, like coding implementations can be a bit more simpler once you get hang of gRPC. So that was it from my side. I hope you are able to get the context around what gRPC is and how you can get started with it in Python. To be very honest, it's one of those libraries that I have felt that in order to get like at least set up in your system and get started, write some hands-on code, is going to be very easy. So I would highly recommend you guys to definitely give it a try. Try to see that how you can write different services and make things faster. Yep, that was all from my side.
Thank you, Sanket. We have a lot of questions from Slido, so I don't think we will be able to answer all of them, but I think you can meet Sanket later too, and we will answer you. The first one, is there a good gRPC Python library which use async IO and typing, like say something like Pedantic or?
So talking about the gRPC library, Google already provides it. So if you will go to the documentation for Python, you are going to find it. So Google already by default provides it.
Okay, thank you. And what if Google decides to kill gRPC?
What if Google decides to kill? I guess a bigger question is, what if Google decides to kill the search? So, I don't know. I don't know. Maybe we have to see for alternatives. But again, yes, gRPC, like REST is more or less like a convention, right? REST is not something like very concrete, a library, or JSON APIs are something very concrete. So gRPC is something, an amalgam of both. It comes with some conventions also, comes with some libraries also. According to the convention, if one convention that I would like to mention is your REST APIs are resource oriented, gRPC API, like the services are going to be action oriented. So obviously Google has done a tight coupling between the convention and the libraries. And yes, if Google decides to kill it someday, we have to look for alternatives. But I don't think REST is going to go anywhere. And I don't think Google is going to kill it because, as I said, we also use a lot of gRPC, quite a lot of it. Few of my friends work at Amazon. Few of my friends, like I also interacted with few people here who are using gRPC in their services. So I don't think with a lot of dependency there, it's going to kill it. But I don't know.
Thank you. And what are the differences between gRPC and Corba?
I don't have a lot of context on it. Maybe I need to get back to like who asked this question. Maybe we can interact with it. I need to get okay. I need to see the differences directly. Okay.
And you compare gRPC mostly to REST. On the other hand, are you aware of any ongoing effort for mixing the best of GraphQL and gRPC? For example, the flexibility for the client in GraphQL when querying, and the high performance of gRPC?
I'm not aware about any ongoing efforts by Google if they are doing something around an integration around the best of both the worlds from GraphQL and gRPC, or maybe best of all the worlds from REST as well, because I have never interacted with the team who builds gRPC. But yes, I believe this can be a good thing. This can be something that Google should try to, but I don't have any idea on that. And even if I had, I'm not sure if I can say that.
And can we use protocol buffer in REST, like generating REST?
I don't directly think so, because you need the compilers and the generators that is provided by, that is directly supporting protocol buffers. But I need to check if there are some libraries that can help us to convert the protocol buffers, the data in the protocol buffers to some JSON things. But I have never used it. I have never used it.
Thank you. And can you use it with existing frameworks like Flask?
Yes, I believe there are. Okay, so talking about Flask. Flask is one of the most minimalistic, unopinionated framework that I have worked with. And you just saw that, right? We have to just write few of our code for server and client, just like normal library. So it can directly interact with things like Flask. You can definitely consume it in Flask. I definitely believe it. So at Google, we have our internal frameworks for C++, Python, and Java. And it becomes really easy because those frameworks also support both REST, HTTP, and gRPC as well. So I don't think there should be some problem. But again, it's about exploration.
Thank you. And one last question from Slido, then probably we have time for more questions from the floor. You mentioned that gRPC handles load balancing as well. Can you elaborate? As far as I know, for gRPC on the web, for example, you need a gateway to translate to gRPC such as Envoy. Isn't that
Sorry,
case?
I lost the second part.
Okay, sorry. You mentioned gRPC handles load balancing as well. Can you elaborate?
Yep. So I already knew that it can be a question that can come. So already, if you will see the slides, there is a very good link using which you can read about how to interact with the load balancing capabilities of gRPC. One second, I can also open that. Where is the cursor? Okay, I lost the cursor. Okay, is it there? So if I go here, and there's a very good article, I'm not sure why, by Microsoft, but you can see, like, you can read this article. I have linked most of the relevant documentation that is required for understanding how exactly the capabilities of gRPC is going to be handled. Right, so you can read about this. It out of the box comes with the capability around load balancing, right? It's not so that you can see the strategies, pick first and round robin, two strategies that are already available, and it's going to be super easy, right? You can just configure what type of load balancing you want to have, and things is going to be easy, right? So again, I believe the documentation are super good. You can read about it, and I have linked everything in the slides. So anything you want to get started with, I believe I have it here. Medium articles, official Google documentation, and I'm not sure why a Microsoft documentation. I believe nobody is watching from Google.
Okay, so no more time for question, but you can ask directly to Sanket later.
Thank you, guys.
Thank you so much.